Okay, we are going to get a little bit more detail about the statistics I've been talking about in the first video. Here you see again the variables and levels of measurement. I brought it down to two levels, a nominal level and a ratio level, and one variable and two variable. If you have one variable on a nominal level, you can calculate the mode and you can represent that with a bar graph or a pie graph. If you have two variables, nominal relationship, and you want to calculate whether there is a relationship between these two variables, for example, let's say gender and political choice, whether a certain political party is more favorable to women or not, in order to do that, you have to calculate the percentage difference, or you can take a more complicated statistical tool like a chi-square test. I'm not going to talk about chi-square, I will stick to percentage differences. In order to make a visualization of that, you can do a double bar graph. If you have a ratio level, you can do all the calculations for an average. So you can do mean, medium, and mode. Standard deviation, of course, and you can represent that in what is called a histogram and also a line graph. Relationships between variables of ratio level is a correlation, regression, and you can represent that in a scatter diagram and a trend line. So this is only summarizing what I've been talking before. Now, let's give a little bit more detail. Here you can see the distributions and the relationship between the three averages. You have the mean, and the mean is just the sum of all the frequencies divided by the number. You have the median, that is the exact mid position. So if you say, for example, the median age in a certain country is 21 years, it means that 50%, half of your population, is younger than 21. And the other half, of course, is older than 21. The mode is the average that tells the largest category. If you have the modal income, that means the income most people earn, right? Generally, when you have this type of distribution, this is called a normal distribution. As you can see, it's also symmetrical. In that case, mode, medium, and mean are the same, and they have the same position here, exactly in the middle. However, most distributions, normal distributions, are not symmetrical. For example, here, your income distribution, like this, let's take this one. Your income distribution, for example, could be something like this. So it starts with a lot of low income and then it goes steeply down for the higher income. It means that the modal income, so to say, that is what most people earn, gives you the highest category. The medium income would be much lower because a lot of people have a lower income. And the median, that splits it even into equal parts, is also higher than the mean, but less than the mode. So when you're talking about, for example, incomes, and the income distribution is not symmetrical, it is the choice. You have to make a choice. Which average gives you the best picture? And in this case, a modal income. Here the same, because it's skewed to the right. It's also not symmetrical, and you see that the mean is very much influenced by the extremes. In this case, the highest, and in this case, the lowest. So you have to be aware about which average you are choosing. Sometimes you have no choice. You can only give the mode on a nominal level. But when you talk about a rational level, then you have the choice at different averages. And when the distribution is skewed, that is not symmetrical. You have to make a decision which average gives the best impression of your distribution. So for income, you generally use mode. For ages, your age distribution, you generally use a median. And in other cases, you can try to use a mean. Okay, let's go one step further. I said, well, we have the mean, but also the dispersion, the distribution around the mean is important. Here in this left picture, you see a distribution which is symmetrical, but with less variability. The variance here, that is the distance between the minimum and the maximum, also called a range, is small compared to this one. Here is more variability. So knowing about the variability tells you something about where the actual values are, how far from what is called the average, how far the values are from the average. Here you get an idea. If you calculate the standard deviation, I'm not going to talk about how to calculate it, but that's a standardized distance from the average. If you do one standard deviation to the left and one to the right, you will have 68% of your values will be in that range. So if you took 2 standard deviations, it counts up again 26, so you have about 95, I think, yes, 95% of your values are in that range. So your standard deviation, which is the square root from the variation, so there is a relationship between standard deviation and variation. When your standard deviation is small, this area will be smaller. And when it's large, this area will be larger. So your standard deviation and your variance, variability, will determine how wide the range of your values are. Okay, so that's background about the averages and the distribution around the averages. Now about the relationship between variables. Here we go. You can see it here. These are scatter diagrams. Take, for example, length and weight. If this is your length and this is your weight, and you have your values here, then you call this a perfect positive relationship. This line is called the regression line. Here you can see it again. It's not perfect, but you can draw a line, which is the trend line, so to say. And this relationship is 0.8. This is a 0.3. Here is a 0. And here you will see the opposite. Because here, a length going up in length goes together with a decrease in weight. So your weight is here and your length is here. So you will have this type of distribution. In a positive relation, the increase of one variable goes together with the increase of the other. In a negative relationship, the increase of one variable goes together with the decrease of another variable. So correlations, and R is a measure for the correlation, gives the strength of the relationship between the two variables. So you talk about a positive and a negative relation, and that could be very strong or not. So here are the examples. Well, you can only do that. These scatter diagrams, and trend lines, you can only do that for ratio levels. If you have something else, here we have another example, which is about the married status. Never married, married, divorced, widowed, and the level of education. So here, and we're trying to calculate the relationship between your marital status and your educational level. You cannot calculate here a scatter diagram and a correlation, because you are talking about nominal levels. At least here, this is nominal. Perhaps here you can bring a certain order, but that's then an ordinal level. So what you have to do is calculate the percentage difference. But in order to calculate the percentage difference, you have to make the numbers in each category the same, meaning you have to calculate them on the basis of 100%. If you have 100% in this column and 100% in this column, then you can calculate the difference between them. That is between 46 and 16. Because now they have an equal number here and they are both 100%, and then they can show how big the difference is. So that is about calculating differences. When you calculate differences, you should always compare square on the calculation, on the direction of calculating the percentage. If this is 100%, you compare it in this way, right? Good. Last sheet. Here is a bar graph. Again, it's all 100%, and then in the 100%, you can see the different categories. And now you can compare the differences between them. This is what I call a stacked bar graph. So you have the different categories in one bar, and they are comparable because they are all 100%. Okay, that's it.